Bismillahirrahmanirrahim. Welcome to the quantity survey course. In our today lecture, we will discuss the how to calculate the bar bending schedule (BBS) of one-way slab. Before going to our topic and explanation with example, first I want to explain you what is one-way slab. One-way slab is a slab which is supported by a beam on the two opposite sides to carry the load along one direction. The ratio of longer span to the shorter span is equal or greater than 2, considered as a one-way slab, because this slab will bend in one direction and in the direction along its shorter span. This is the formula to calculate whether the slab is one way or not. Longer span divided by shorter span, if it is equal to or greater than 2 value, then it will be one way slab. Here in our case we have 7000 longer span millimeter and 3000 shorter span millimeter. So we divide it, our value is 2.33, it's greater than 2, it's mean our slab is one-way slab. So we will design it or make the bar bending schedule of our slab as a one-way slab. So due to the huge difference in the length, the load is not transferred to the shorter beams. Main reinforcement is provided in shorter span and the distribution reinforcement in a longer span. So we start our topic with practical explanation of example. Here is our slab. You can see our longest span on x-axis is 7000 millimeter and the shorter span is 3000 millimeter. So we just divided the longer span with the shorter span and our value was 2.33, greater than 2, it's mean our slab is one-way slab. So in here our slab is cut by this section AA, and these are the main bars along the shorter span. This is shorter span. Along the shorter span we have main bars, and main bars are bending from one end, and this is also called as a alternative bending. Alternative bending mean first one bar is bending from this side and other bar is straight from this side but bending from other side. So this is main bar provided with one bend, called alternative bending with main reinforcement. And here these are the black showing the distribution bars provided. These distribution bars are the straight bars. There is no bend in the distribution bars. Here you can see the distribution bar dia is 12 millimeter and center to center spacing is 150 millimeter. Here I want sorry for it. Here our distribution bar dia is 8 millimeter and the space between the distribution bar center to center is 150 millimeter, and the main reinforcement bars having 12 millimeter dia and the spacing between the main bars is 150 millimeter center to center. Here you can see just only two main bars and only two distribution bars, but these are just showing you, otherwise there are bars provided in whole slab with the center to center distance 150 millimeter and 150 millimeter distribution bar. So let's move further way. This is the section showing of the slab, section AA. In this section you can see these dotted bars with brown colors are the distribution bar, and these bars are the which are bending here at 45 angle, these are main bars. This bar here, I want to show you that this bar is bending from just one side and other bar is bending from this side with 45 angle but straight on the other side. So here you can see this is one bar bending from here with 45 angle, then it is straight going here. Then other bar is bending from here at 45 angle, then it's going straight here towards here. And this is in the section you can see this is the above this is a wall, so that is the development length of the main bars. After this is the development length. These length are getting support on the wall. So these above, after these dotted lines, there are development length of the bars. Here I want to show you on the this side of the, we provide on the shutter span of this side, we provide beams in the one-way slab. Here we will provide a beam and here we will provide a beam, but here I am not going to show you beam because our topic is bar bending schedule of one-way slab. So we will just do the bar bending scheduling of one-way slab. Let's move further. Here I want to tell you this thing, that this 45-degree bend is length can be calculated by this formula 0.2 0.42 h. H is here height from this bend length, this main bar to this main bar, from center to center distance is called h, and here we multiply h with 0.42 to calculate this bending length. And this bending length here is the height, so both side height will be same, so bend length will also be same because both are bending at 45 angle. The depth of the slab is 150 millimeter. So given data we have, size of the slab is 7000 by 3000 millimeters, 7000 longer span, 3000 shorter span, and thickness of the slab is 150 millimeter. We have main bar dia is 12 millimeter and the spacing between the bar is 150 millimeter center to center, and the distribution bar having the dia of 8 millimeter and the spacing between the distribution bar is 150 millimeter center to center. And we provided the top extra bar. Here I will show you in the section. In the section you can see where bar or main bars are bending. There we in the yellow color you can see these are the top extra bars we provided along these distribution bars, but distribution bars are at bottom and top extra bars are at the bending. So here you can see, so these are top extra bars, and the dia of the top extra bars is also 8 millimeter and the spacing is 150 millimeter, and clear cover from all the sides of the slab is 25 millimeter. Calculation will be in two steps. We will do the calculation of BBS in two steps. First we will calculate the number of bars, number of main bar, number of distribution bar, and number of top extra bar. Then we will calculate the cutting length of main bar, distribution bar, and top extra bar, and finally we will calculate their weights. Let's start the solution of this numerical. So first we will calculate the number of bars. Formula to calculate number of bar: total length means clear cover from both the side divided by center to center spacing plus 1. So number of main bars will be, here I want to explain you in the plan view that to calculate the number of these main bars, we take this length to the opposite length to the main bars. We take this length, longer span length we will take to calculate the number of main bars, whether the main bars are provided at the shorter span, but we will take opposite length to calculate the number of main bars. And same for the distribution bar, we will take the shorter span length for the distribution bar, whether the distribution or bars are provided at the longer span, we will take the opposite length to calculate the number of bars. So let bars will be, our bars are provided at shorter span, but the opposite length is longer span length is 7000 millimeter, minus 2 clear cover from both sides. That's why we multiply 2 with the 25 millimeter. We know that 25 millimeter is a concrete cover from all the sides, so we will subtract it from the total length and divide it by the spacing bit, center to center spacing of the main bars, which is 150 millimeter plus 1. This is formula. Calculate the number of main bars. 7000 minus 50, 6950 divided by 150, 46 plus 1, 47.33. Total we require, we take it 48 number of main bars for our slab, having longer span of 7000 and shorter span of 3000. But the number of main bars are provided along the shorter span. But to calculate the number of main bars, we take the opposite span, longer span. Calculate number of distribution bar. To calculate the number of distribution bar, as we know that number of distribution bar are provided at the along the longer span, which is 7000 millimeter, but we will take the opposite length to calculate the number of bars. So here we will take the shorter span length to calculate the number of distribution bars, minus 50, it will give us 2500, 2950. 2950, then divided by the spacing, center to center spacing, 2950 divided by center to center spacing is 150 millimeter of the distribution bar plus 1. So 20.66, we will take 21 number of bars required for number of distribution bars required for our slab along the longer span. So no longer span length. So we move to the number of top extra bars we required. To calculate the number of top extra bars, first we have to calculate the length on which we will provide the extra bars. I will show you it in the section of in the slab section. You can see these are the top extra bar provided along the length after the bending of these main bars. So to calculate this length, we have formula L by 4. We have formula L by 4. So first we will calculate this length. Then we will calculate the number of top extra bars, L by 4. So we have L here, the so we know that the top extra bars are also provided along the distribution bar, but distribution bars are at the bottom, and the top extra bars are at the top where the after the bend they are provided. So these are along the longer span. So we to calculate their number, we will take the shorter span length, which is 3000 divided by 4, L by 4 we have formula. It will give us the 750 millimeter. Then to calculate the number of bar, we have the same formula for the top extra bar. Total length minus 2 clear cover, which is 2 into 25, and divided by the spacing. Spacing is same for the top extra bar, 150 millimeter plus 1. Let me calculate it now. 750 minus 50 will be 700. Let me calculate it on the calculator now. 700 divided by 150 plus 1. We required 5.66, means 6 number of top extra bars at one side. Here I want to show you that we required 6 number of top extra bars. We required 6 number of bar at one side here, and other side will take same bar because length will be the same. So total number of bar, top extra bar, we required 12 number of extra bars. So we will multiply with the 2 because we have two sides. So it will give us 12 number of bars, top extra bars we required for our slab. Let's move next. Cutting length calculation. First we will calculate the cutting length of main bars. We have the formula to calculate length minus 2 clear cover plus 2 into LDI, where LD is the development length, plus 1 into 0.42H, 0.42H inclined 45 degree length formula to calculate the inclined length, and 1 here we multiply because we have one bend at one main bar. I want to show you the main bar. In the plan view you can see one main bar having one bend, so that's why we multiply 1 with the 0.42H. 0.42H is this, the to calculate this length is the formula. Here in section view you can also see this is the formula to calculate this bend length, and in one main bar we have one bend length, so that's why we multiply it with the 1. So this is the formula to calculate the cutting length of the main bar. Minus here we did minus 2 into 1D. 1D means 45 degree bends. So we in one bar we have two 45 degree bends. So that's why we deduct 2 1D. 1D is the 45 degree bends formula. So that's why we multiply with the 2. You can see this is 145 degree bend and this is other 45 degree bend. So we have two 45 degree bends in one bar. Here in the plan view it will be more clear. This one bar having one bend length, and this one 45 degree bend, and this is other 45 degree bend. So total one main bar having two 45 degree bends. So to put the values in this formula to get the cutting length of main bar, first we will determine this H. So H formula is slab thickness minus 2 clear cover from the top and the bottom minus 2 half dia of bar. Here I want to show you in the section how this formula is tried to calculate the H. Get to the section. Here in the section you can see H is this main bar bending from here to here 45 degree. So from the center of this bar to center of this bar we will calculate the H. This is the H value from center of this bar to center of this bar. This is H value. So that's why we deduct the top and bottom concrete covers and then we multiply the, because we go from the 2 into half dia bar, because we go from center to center. So let's we move to the cutting length. Here 2 into half dia bar to go from bar center to center main bar. So here we will calculate 150 minus 50 will be 100 minus 12 will be 88 millimeter. Now put all the values in cutting length of main bar formula. Here length we have 3000. We are calculating the cutting length of main bar and the main bar are provided at the shorter span. So shorter span length is 3000 millimeter. So plus 2 into 40 D. D is the dia of main bar. Dia of main bar is 12 millimeter and 40 is the development length formula. Development length here LD formula is 40D. So here we put the 40 into D dia of main bar 12 millimeter plus 1 into 0.42 into H. H value we have 88 millimeter. So next we have minus 2 into 1 into D. 1D is the 45 degree bend. This is the bend length formula. So here we have two bends, 45 degree bends in one bend length. So that's why we multiply with the 2 1D for the formula of 45 degree bend. Let me add these values now. First we have 3000, then let me calculate it on the calculator. 2 into 40 into 12, sorry, 2 into 40 into 12, 960 millimeter. 960 plus 1 into 0.42, 1 into 0.42 into 88, 36.96, 36.96 and the minus 12 into 2, 24. So let's we finally calculate it on the calculator now. 0.96 plus 960 plus 3000 minus 24. 3973. Let's we take it in 73. 3973. 3973 millimeter. In meter it will be 3.973 meter. We required the cutting length of one main bar. To calculate the total cutting length required for total number of bar, let's we multiply with the number of main bar. Number of main bar we have 48 number of main bar. So multiply 48 with the one cutting length. 48 into one cutting length we have 3.973. Let me calculate it on the calculator now. 48 into 3.973. So total cutting length required for all main bars, which are 48 number of main bars, we required 190.70. We take it 191 millimeter. 191 meter length required for main bars, which are 48 number of bars. So let's finally calculate the weight of main bar. We have the dia of 12 square divided by 162, and length we have 191. Let me calculate it on the calculator now. 12 square divided by 162, 0.88, then multiply it with the 191. So 169.77, take it 170. Okay, 170 kg. Let's move further to calculate the distribution and top extra bar. So distribution bar, to calculate distribution bar we have formula L minus 2 concrete cover plus 2 LD. LD is the development length, which is formula is 40D. So here we do not have any 45-degree bends in distribution bar, because our distribution bar are the straight bar, and our top extra bars are also straight bars. There is no bend in the distribution and top extra bar. I want to show you in the plan view also. In the plan view you can see these are the straight bars provided, distribution bars. These are straight, no bends, so that's why we did not deduct any bend. Just we have to deduct two concrete cover from the side for the distribution bar and for the top extra bars. Here you can see top extra bars. So let me put the value here. L for the distribution bars are the provided at the longer span, which is 7000 millimeter, minus 2 concrete cover from both sides, plus 2 into LD formula we have 40D, 40, and dia of the distribution bar we have 8 millimeter. We multiplied it. Let's we calculate it on the calculator now. 7000 minus 50, 2 into 2550, 6950, 6950 plus, sorry, plus 2 into 40 into 8, 2 into 40 into 8. So this is 640. 640. Let me sum up them. 640 plus 6950. So total we have 7590. 7590 millimeter cutting length of the distribution bar, one distribution bar. to calculate the total cutting length of distribution bar, we first here now to total, we have total number of distribution bars 21. To multiply one cutting length with the number of distribution bar, first we will divide it by 1000 to convert it into meter. In meter we have 7.590 meter is the one cutting length of distribution bars. Total number of bar, distribution bar we have 21, multiply with the one cutting length. One cutting length of distribution bar we have 7.590. Let me calculate it on the calculator now. Divide it by 1000, 7.59, then multiply it with the total number of distribution bars. We have 21. So total cutting we require 159.39 for the all distribution bars. So let me take it 160 meter. 160 meter. So let me calculate the weight of the distribution bars. So weight of the distribution bar, we know the dia of the distribution bar is 8 millimeter, 8 square divided by 162. Length we have 160 meter. So let me calculate it on the calculator. 8 square divided by 162, then multiply it with the 160, 63.2. So we require a weight for this 63.2 to take it 64 kg. Weight is the of the distribution bars. So here I want to show you top extra bar cutting length will be the same of the distribution bar, because top extra bars are also provided at the same length, because top extra bars are provided along the longer span and the distribution bars are also provided along the longer span. But here we only have 12 number of top extra bars, so we will multiply 12 with the cutting length of distribution bar. We have the cutting length of the top extra bar will be the same, formula is same. So we will take here cutting length of one bar is 7.590. So we will multiply with the 7.590. So it will give the, let me calculate it on the calculator now, into 12 into 7.590, 91 meter. We required 91 meter. Length top extra bar. So here we already calculated 91 meter. Let me calculate the weight of the top extra bar. So weight top extra bar dia is same 8 millimeter. Let me calculate it on the calculator now. Here we will go to the length 91 meter. 8 square divided by 162, multiply with the total length of the top extra bars, which are 12. So total length 91 meter. So total weight required of the top extra bar is 35 kg. 35 kg weight of the steel of the top extra bar required, which are in number 12 in number. So here I want to show you how the distribution bar and the top extra bar cutting length is same. Here you can see this is the distribution bar provided straight, and the top extra bar is provided at the top here, but it's not showing in the plan view. Here I want to show in the section view. You can see these are the top extra bars. These are the bottom. These are the distribution bars provided at the bottom. These are the top extra bars, which are just provided after the bending here at the top. So these are in 12 number, but these are also provided at the same longer span. So their cutting length will be also the same like these distribution bar, but there is also no bend in the distribution and top extra bar, though their cutting length is same. So we calculated it. Let me now finish this topic now. Finally, we will calculate the total weight. Total weight, we have total weight of the steel. For main bar, we have the weight 170 kg. 170 distribution bar, we have weight 64. Remember this, 170, 64, and top extra bar, we have 35. 170, 65, and 35. 170 plus 65 plus 35, total we have, let me calculate it on the calculator. 170 plus 65 plus 35, 270 kg is the weight required for this, weight of the steel required for this slab, 270 kg. Okay, thanks for watching this lecture. Please stay tuned for next.